Hello students, welcome you all into the Jaswal Edu Maths. Today we have a question of a determinant. If A, B, C are cube roots of unity, then you need to find that the determinant, what is the value of the determinant. Here we have to first crack this, what is A, B, the cube root of unity. A, B, C are the cube roots of unity. So you can write it like this. Suppose X is equal to cube root can be written like this and unity is 1, you know that. So when you cubing both sides, you'll get x cube equal to 1 raised to power 1, yeah, and x cube minus 1 equal to 0. When you factorize it, you'll get x minus 1 and x square uh, plus x plus 1 equal to 0. Okay, in this case, when if x minus 1 equal to 0, then you would get x equal to 1 is one of the factor, okay, one of the zeros, since x minus 1 is the factor. And when you factorize this x square plus x plus 1, then by using discriminant method, minus b, what is minus b? B is 1 plus minus root d, what is root d? Is b square minus 4c is 1 square minus 4a is 1, c is 1. So in this way, upon 2a, what is 2a is 1. So you'd get here minus 1 plus minus 1 minus under root minus 3 upon 2. In this way, you can so 1 plus minus, you can write at the place of root minus 1 iota, okay, upon 2. So since we have given that a, b, c are cube roots of unity, so we can assume a as 1, b as minus 1 plus root 3 iota upon 2, and c as minus 1 minus root 3 iota upon 2. Okay, so what you see, you observed here that when you add these three, like a plus b plus c, what would you get here? When 1 plus minus 1 plus root 3 iota upon 2 plus minus 1 minus root 3 iota upon 2. When you take LCM, you'll get here, you'll solve, you'll end up with 0 here. So in this case, you're getting what? A plus b plus c equal to here 0. Alright, so we would use this observation where we found that a plus b plus c equal to 0 equal to a plus b plus c equal to 0 in the question. So now we are now a plus b plus c equal to 0. What next? You have to focus on this what determinant. Now since we see that in the third column, you see sum of two terms. Okay, so we can separate it out by using sum of two different determinant like this: e raised to power a, e raised to power b, e raised to power c, e raised to power 2a, e raised to power 2b, e raised to power 2c, and separate it: e raised to power 3a, e raised to power 3b, e raised to power 3c. Okay, plus what you can do here, you can write in the third column minus 1 minus 1 minus 1. Alright, minus 1 minus 1 minus 1, and let me fix this. Okay, yeah, and in the first column, e raised to power a, e raised to power b, e raised to power c, and second, e raised to power 2a, e raised to power 2b, e raised to power 2c. When you take, okay, here you see in the third column, you see here minus, okay, that means minus 1 is multiplied in all the elements of column third, so you can take it out, and when minus comes out here, it will become minus here. Okay, so in this way, what do you see? What have you observed here? I have observed that we can take out common from e raised to power a from here, okay, and in the first row, in the second row is to power b, and we can take out e raised to power c in third row, because we know the rule of by the rule of matrices, if we take, that means take out multiple, it doesn't, from indivisible row or column, okay, we can take out multiples. So we are getting same multiple here, so we can take out e raised to power a, e raised to power b from the second row, e raised to power c from the third row. So what would you end up with? Okay, so let me fix it. Okay, here, yeah, this one is okay. So e raised to power a, e raised to, sorry, what would you get? 1 1 1. After taking out e raised to power a, it would be e raised to power 2a. When you take out e raised to power b, it would become e raised to power b, e raised to power 2b. Here e raised to power c, e raised to power 2c. Alright, minus, what would you do? Here you have to make the face of this determinant similar to this, or this determinant, this one similar to this determinant. So what would you do? Just that means at the first column you need to place this, so you can interchange these two values, two columns, like you can apply C3 interchange C1, okay, vice versa you can. So when you interchange two rows or two column, then the value of determinant, the absolute value of determinant is same, but the sign change, okay. So minus and minus will become here plus. Alright, and you write here the value after interchanging the determinant, sorry, interchanging the column. So 1 1 1, e raised to power 2a, e raised to power 2b, e raised to power 2c, no change, but we are interchanging e raised to power a, e raised to power b, e raised to power c. What we need in the second row, sorry, in the second column, we need e raised to power a, e raised to power b, e raised to power c here, because we need to make a similar here result here also. So we can do what? We can do the interchange C1 interchange. What we can do? C2 interchange C3. Alright, C2 interchange C3. Again the value of determinant here change, okay. So e raised to power a, b, c, that means e raised to power a plus b plus c, you can write like this. And here in this case 1 1 1, e raised to power a, e raised to power b, e raised to power c, e raised to power 2a, e raised to power 2b, e raised to power 2c, plus, what would you get when you interchanged this, the value of determinant, that means the negative value you get, okay. Now 1 1 1, after interchanging the row, the column second by column 3, you'll get here e raised to power a, e raised to power b, e raised to power c, e raised to power 2a, e raised to power 2b, e raised to power 2c. Here you get the similar result. So this determinant is similar to this. So here we have to crack this. What was the value? Here we have found that e raised to power a plus b plus c is equal to 0. So e raised to power 0 would be here 1. Okay, so I can at the place of e raised to power a plus b plus c, we can write what? 0. Alright, sorry, not e raised to power 0. And what is the value of e raised to power 0? It would be 1. And the similar determinant, okay, when you solve this, if you find the value of this determinant, when you subtract the similar one, okay, by the similar value with the when you subtract two similar values, the result will be 0. So in this case, the value of this determinant is 0. Okay, let's move to the next question. Here we have another question, and the question is, find the value of this determinant b plus c, okay, c plus a A plus B, C plus A plus B, B plus C, A plus B, B plus C, C plus A, and it is equal to K times A, B, C in the second column, B, C, A in the third column, C, A, B, C, A, B. Okay, so here I'm going to fix it. Okay, this one. Okay, so here you have to solve. So of course we would work on this left hand side, and so here you have, in the left hand side, you have to apply the properties of determinant. So apply here, C1 changes to C1 plus C2 plus C3 like this. When you apply this, so what would you get? C1 plus C2 plus C3. That means you'll get 2A plus 2B plus 2C. Okay, here in each case, C, C2, C. Okay, alright. So we can take 2 common, A plus B plus C, 2 again A plus B plus C, 2 again A plus B plus C, and a similar result, 2 C plus A plus B, B plus C, A plus B, B plus C, C plus A. Okay, so you can take out what the common multiple here in the column from column 1. So 2 will come out, and you can write 2 outside. So you can ask me that why I'm not taking out A plus B plus C, because we need this. Okay, since we need what? A B C, B C A and C A B, we need the similar result. When we remove this, you'll end up with 1 1 1, because we don't need in the right hand side, we see we don't need 1 1 1 in any column here. So we are not doing with this. We are not taking out A plus B plus C that means common here. Okay, so what we will do next, we can do here, we are now going to apply. When you subtract C2 by C1 and C3 by C1, what would you get? Here C2 changes to, you can write C2 minus C1. Yeah, and C3 changes to C3 minus C2. What would you get here? You would get here, the C1 would not change, A plus B plus C, A plus B plus C, A plus B plus C. And what would be the result here? And when you subtract this, you'd get here minus B, A plus B minus C, B plus C minus, okay, so minus A, alright, A plus B minus C, B plus C, then minus A, C plus A, then minus B will get after subtracting. Then after, what do you have to do? You need to again apply you need to find what? BCA, CAB. Alright, okay, alright. So we can apply here, C1 changes to C1 plus C2 plus C3. So what would you get here when you apply this? C1 changes to C1 plus C2, the B minus C, and you would get here A minus B minus C. You'd get here B minus C minus A. You'd get here C minus A minus B, like this. Okay, so what do you see here? You get the same result here, A B C, B C A, C A B, but in column second and column third you are getting minus 1, multiple of minus 1 here. So you can take out from column 2 as well as from column 3. So when you take out minus 1 from column 2, the minus will come out like this. Okay, and when you again take out minus 1 from column 3, again 1 minus again come out here like this, and minus minus will become here plus. All right, so now you're getting the same identical value, and when you compare this with this, the right hand side, you'd get here the value of k is equal to what, 2. At the place of here, when you compare the result, okay, the right hand side, you'd get k equal to 2 as answer. Thank you very much for watching this video.